All right, so here's today. Yesterday was chords. Today we're going to talk about, just a reminder, those are called secants. Intersects the circle twice. And then this bad boy over here we called a tangent line. So today we're going to talk about, hey, how do I find the lengths of those? All right, we know how to find the lengths of chords, and I can tell you this, it's different. I know your mind right now is, oh, I'll just do AB times BC equals AD times DE. That's not how that works for these. That's only for chords. All right, tangents and secants, here's the rule. And it's not even a formula I'm going to give you. It's a saying. All right, it's a saying. And here's the saying. You take the whole thing, all right, however long the whole thing is, the secant or the tangent, and you multiply that by, ready? Its external part. Its external part. So the part on the outside. Whole times external. So I take the whole thing times how long it is on the outside, and I set that equal to, there's always going to be two of them. Two secants, a tangent and a secant. So I do the same thing on the other one. I take its whole length and multiply it by its external part. Whole times external for tangents and secants. Go to my first diagram where I have two secants. What would I set up here to figure out how long any of the pieces are? Well, give me a whole secant right now. Name a whole secant in that diagram. There's two of them. Using the letters, name a whole secant up there for me. Let's start this off right. I'll get there here. Awful. Keating? CBA. So I'm just going to say CA, the whole secant, times its external part, which would be what? If Keating's going to pick secant CA, name the part on the outside now. Multiply CA with Zoe? BA. There you go. Whole times external. Now there's another secant. I set that equal to, name the other whole secant for me. Name the other whole one there, Jonathan. EA. Times its external part. What's on the outside of EA? That is segment. Just waiting for me to call on you, Sydney. BA, good.
No, DA.
Oh, DA, yeah. Thank you. One jab. I got rattled by the number. All good. All right, watch what happens when we do a tangent now. Okay, watch what happens. Let's start with the secant. Name the secant in the second diagram for me. I'll start with the whole secant up here first. Whole secant. Where are we going with the whole secant? Jesse, not here. One more time. Taylor, whole secant. DCB. Yep, so DB times, now give me the external part. External part up there. Whoa, going deep on that one. Alex? CB. All right, I'm not trying to fool you here. Just want to make a point. Name the whole tangent. Whole tangent segment up there is? Whole tangent segment, Keating?
AB.
AB. And again, not trying to trick you. Name its external part now. Name the external part. I won't throw you in the fire yet. Izzy? Also AB. So the whole and external part are both the same for a tangent. Okay, both the same value. All right, all good? Whole times external. Again, this is only for tangents and secants. Chords we dealt with yesterday. That's a little bit different. All right, first one up. I know what your mind wants to do right now. Everyone's mind wants to do 5 times 10 equals 4 times x. That's yesterday. That's chords. These aren't chords. I got to do whole times external. I know the mind's in, right? You're in that mindset to do 5 times 10 equals 4 times x. If they were chords, that'd be correct. All right, but I got to do whole times external here. So what I want, just give me any whole secant length. Any whole secant length right now. I'll follow your lead here. Rowan, one whole secant length. So I take 15 times the external part. Rayhan, what's the part on the outside for the secant? What, 5? Good. All right. Now watch your mouth here. What's the other whole secant length? And it's not 4x. All right, I don't multiply those two there. All right, it's not 4x. How do I write how long the other whole secant's going to be? Let's go there, Jayla. 4 plus x times its external part. What's the part on the outside there, Lennon? 4. All right, so that's how that one is set up. There's a good whole times external there. And I know you're going to get decimals. It's okay. You're in an above average math class. It happens. It happens. That's why I have rounding directions. That's why we have rounding directions on this one. And go ahead when you have it. What do we got? Nearest 10th we're rounding to here. Nearest 10th. Whoa, Sydney, when you're ready. 14.8. Good work. Okay, no issues yet. So now all the best thing you can do, keep it separate from the chords from yesterday. Keep this separate. Whole times external. All right, next one up. Give me the whole secant length here. Whole secant length. Whole secant. Taylor, whole secant length. Secant. 11. How about its external part here? Is the external part? 2. Whole tangent here, because this is a secant and a tangent. What's the whole tangent length right there? We're going Zoe. Y, yep. And then we also said the external part when you deal with the tangent is also the same. (22) equals, oh, get out of here if you're giving me 2y. We went over this yesterday. This is y squared. And nearest 10th when you have that ready. Shoom, Rowan, what do you got, big dog? 4.7. You guys are machines today. Take a breath. Ready to go on to number 3. Again, number 3, I know some of you might want to do 8 times y equals 7 times y plus 3. That's for chords. These are secants. So give me a whole secant length over there. Whole secant. Either one's fine. Rowan, back to you. 8 plus y. Times, how about its external part up there? Just say. Rowan! Here we go. Let's go. 8. All right, take your time. Other whole secant. Combine your like terms before you tell me, please. All right, combine your like terms. How long is the other whole secant up there? All right, new one there. Halo. Y plus 10. And how about its external part? What are we going with that one there? Shoom. Zoe, back to you. 7. Good work, everyone. Take your time with your distribution. Shoom. Take your time when we're ready. When you're ready there, Mia. 6 it is. All right, no issues. All right, well, let's be honest, though. We've been kind of on easy street. Those weren't that bad. All right, can we get a problem that combines what we did yesterday with what we're doing today? Yes, we can. Here's number 4. All right. Let's keep with this whole times external deal. Everyone sees the tangent, right? And does everyone see the secant? NQM? If I start calling on people, there's my tangent, there's my secant. If I start calling on people and do whole times external, anybody going to see the problem we're going to run into? Quick. Yeah. I take the tangent, it's going to be y times y. I take the secant, what variable is going to be there now? X. We don't want that. All right, we don't want a whole times external with a y or an x. So unfortunately, whole times external is not going to work. But what can work is, anybody see two chords that intersect on this one? Yeah, so do I. RQP with NQM. We can go to yesterday, which is part times part equals part times part, because I have two chords there. So we got to go back to yesterday. We'll find X first. All right, so those two chords, first person up, give me the two parts of one chord. Give me the two lengths of one of the chords there. Boom, start us off here. Let's do this. Jayla, give me two parts of one of the chords. All right, so I'm from yesterday, 4 times X. Now somebody go to the other chord and give me its two parts. Boom, deep here. Too deep for me, Izzy. 10 and 3.2. All right, so that's how I had to start it off, because I could not do whole times external. It would have gave me a y and an x. And we should be getting 8 out. I'll take this one, 8 out for x. All right, now plug that in. Did we get 8, right? Yeah, we got 8. Plug that in for x now. Substitute it in. So now we can go to the tangent and secant and do whole times external. I'll do the tangent, y times y. That's whole times external for the tangent. All right, now I'll turn it over to one of you guys. How long's the whole secant? Combine everything now. The whole secant. Okay, how long is the whole secant there? Make sure I know before I ask somebody. All right. The whole secant length, is it? 18. Yep, the 4, the 8, and the 6. And how long is its external part for the secant? How long is its external part, Mia? 6. There you go. That's how I'm going to find y. Whew. And we're still rounding to the nearest tenth, right? And when you have that, let me know, Halo, when you have that nearest tenth. Got it. Thank you. All right, no issues there. A little complicated. We had to use what we had from yesterday, but. All right, this next one, the geometry is not complicated. The algebra is, though. Okay, the algebra is complicated. All right, all this is a tangent and a secant, right? So whole times external. I'll do the easy one. Ready? 10 times 10. All right, how about the whole secant? Combine your like terms now. Combine your like terms before you tell me. Whole secant length there. Keating?
2x plus 4.
Good. Not x squared. 2x plus 4 is the whole secant. Times the part on the outside. How long is the external part for me? True. And Lennon, how long is the part on the outside? All right, good job. There's the geometry, right? That wasn't too tough. All right, buckle up for the algebra. I got 100. We're going to distribute the x. 2, not 2x, 2x squared and 4x. All right. Anybody want to do a next move? Try it out. There's 2 things we can do. Take a shot. Not even take a shot. Go ahead, Taylor. What's your shot? Who cares if you're wrong? Not yet. That's coming up.
You have to bring the 100 to the other side.
Okay, well, I can't do anything until it's equal to 0. Factor, quadratic formula, whatever you want to do, it can't be done until it's equal to 0. So good talk here. Minus 100 over. Zero equals 2x squared plus 4x minus 100. Is anybody thinking anything else? Because there's still something we could simplify before we start talking factor or quadratic formula here. Sydney? Get the 2's out of there. Why not? Right? Get the 2's out of there. So go ahead, divide everything by 2, including the 0, but doesn't really affect the 0, right? So we can divide everything by 2. Remember, it's got to be, if you decide to divide by 2, that's fine, but it's got to be every single term's got to be divided by 2. So now you got a 0 still. We got x squared. We got 2x. And we got negative 50. Now, we could take time now and say, hey, do we know two numbers that multiply to negative 50 but add to 2? And I'm going to tell you, I don't care what trick you use, it ain't happening. We could be here for days doing it. Right? There's not any numbers that multiply to negative 50 and add to 2. It's not going to happen. So Taylor already mentioned it. If you can't factor but still have to solve, we got to use quadratic formula. All right, so reminder, quadratic formula. X equals negative b plus or minus square root over 2a. Let's make sure before we substitute, we know what the a, the b, and the c values are here. All right, somebody want to help me with that one there? Izzy, what's my a value in front of the x squared? X squared, sorry. 1. How about the b value? 2 and the c value? Yep. When you substitute it in, especially underneath the radical, I always like to put them in parentheses. Same with your calculator when you type it in. So let's see, it's going to be negative 2 because my b value was 2. And now I'm going to start placing these bad boys in parentheses underneath the radical. All over 2 times 1. As you're typing it in right now, a reminder, your calculator does not have a plus or minus. So you're going to have to put the plus or the minus first, write down the answer, copy it again, and then put the plus or minus back in. So you should get 2 answers out of this, 2 answers. And then we'll talk about does one make sense or not. Two answers out, one with the plus version, one with the minus version on the calculator. And then we'll talk, hey, does it make sense? Look at your diagram. Does it make sense for one of these answers? All right, ready to go here? Let's see what we got. Let's see what we got in you here. Maddie, got one answer for me, the positive or the negative, doesn't matter.
1.4.
What do you have? 1.4? Is that what you said? Yeah. What do you got in your calc here? -2 plus minus. Come on, Winslow, let's go. Go ahead, let me know when you get it. Either version. -8.1, yep. There's one answer, and the other one. Yes, Jesse, good work. Good talk over there. Good talk. Taylor, what's your deal? How about the positive version? Okay, so you got the -2, right? In this case, would be plus, because Maddie already gave me the minus. So plus underneath the radical, 2 in parentheses squared minus 4 times 1 in parentheses times -50 all over 2 times 1. I got that one. Yep, we got that one. Now take that minus and put a plus in now. Yep, 6.1, nearest 10th. And we talked one's not going to make sense, right? Because there's no way I could have AC be -8.1. All right, you can't have a negative length, so make sure that's rejected. And we're just keeping 6.1. Regents exam, June 11th. This came off an old Regents exam, your last one. Go ahead, on your own. This came off an old Regents exam. Make sure it's whole times external. Whole times external, kids. Oh, we're getting after it here, huh? Hey, 12.5. We don't have 4.5 in our calculation, right? Because that's the internal part. Subtract the 2, we should have 8 as the external. And x equals 10. Or dA equals 10 anyway. Okay, old Regents question there. Yep. And then let's get it rolling. 6, 8, 10, 4 problems tonight. That's all I'm asking. One probably will involve quadratic formula. That's why we did this one. So heads up there.